Okay, so I think it's time to start. So shall we get to it? I guess this is yes. Okay, so good morning and welcome to this webinar on Galaxy and the integration of Galaxy with the AGINFRA plus VREs. Eva already told you this webinar is being recorded, so I hope this is okay for everyone. And after the talk, it will be available for you to watch when it's ended. Although the main target of today's talk is the AGINFRA Plus consortium members, it's open to everyone. So I would like to have two fast slides on the AGINFRA project and myself, so everyone has a kind of a framework of what we are doing. So I will start with the AGINFRA Plus project. This is a 3-year Horizon 2020 project funded under the User-Driven Infrastructure Innovation Call. We are 8 partners, and in this year, 2019, it's the third and the last year of the project. The aim of AGINFRA is to exploit infrastructures such as EGI, OpenAir, UDAT, D4Science for the evolution of the existing AGINFRA data infrastructure to provide a sustainable channel addressing adjacent but not fully connected user communities around agriculture and food. So for achieving this, the project is developing and providing the necessary specification and components that will allow rapid and intuitive development of data analysis workflows and functionalities for data storage, indexing, execution of algorithms, visualization, and so on, using cloud-based services. Furthermore, AGINFRA Plus aspires to establish a framework to facilitate the transparent documentation, exploitation, and publication of research assets, datasets, models, software components, publications, and so on, in order to enable the reuse and repurposing from the wider research community. So that's the AGINFRA introduction. Just a few words about me. I'm Enol Fernández, working as cloud architect for EGI Foundation, which is the coordination body of the EGI distributed computing infrastructure. I have been involved in this kind of computing facilities since 2003, first as software developers for the grid and later shifted towards cloud computing around 2010. And now I'm a member of a user community support team, giving support to user communities. I'm the coordinator of the EGI Cloud Federation. And I also do development of new services for EGI, like the Jupyter Notebooks service that is used in the AGINFRA community, and also this Galaxy integration that is also presented today. Just one disclaimer, I have no background on bioinformatics, so I have done this development and I can understand the inner working of Galaxy, how it's deployed, how to configure it, but I have limited knowledge on the user side of the story. So the examples I will show are rather basic and are mostly intended to get you started, so you can get a feeling of what the tool can do, and from there you can move on. So apologies from the beginning if I show any example that is kind of not realistic, but I hope it helps you to understand the concepts. This is the outline of the webinar today. First, I will introduce Galaxy, what it is and its basic functionalities. Then I will explain how we are interfacing Galaxy with the D4Science Dataminer facility, so we can use AGINFRA from Galaxy. I will do then a short demo of what we have achieved so far, and then we can end with some open questions. So let's get started with Galaxy. Galaxy is a scientific workflow, data integration, and data and analysis persistence and publishing platform that aims to make computational biology accessible to research scientists that do not have computer programming or system administration experience. It was initially developed for genomics research, but now is largely domain agnostic and can be used for any general bioinformatics workflow system. It's an open source project led by several US universities. But not only these universities are contributing, there are contributions from all over the world, including lots of people from Europe. And it's bringing together several hundreds of developers in this community. The core values of Galaxy is to be an open web-based platform for performing accessible, reproducible, and transparent genomic science. So what do they mean with these three things? First, for accessibility, it's known that computational biology is a specialized domain that can require a lot of deep knowledge of computer programming. And the idea is that Galaxy provides the researchers access to this kind of tools without requiring them to understand this kind of programming. And it does that by providing a simple user interface that is completely web-based and that allows you to easily put your data in and get your data out. Reproducibility, it's a key for providing good quality scientific results, and Galaxy supports it by capturing information about every step in a computational analysis. So you can do the same steps repeatedly, exactly at any point in the future. So it keeps track of all the input, the intermediate and final data sets, as well as all the parameters provided to and the order of each of the steps of the analysis. And finally, transparency. Galaxy supports transparency in a scientific research by enabling the users to share any of the Galaxy objects either publicly or with specific individuals. The shared items can be examined, rerun, and copied to your space, or even downloaded and put it into another Galaxy instances. This shows the main interface of Galaxy, where we have three panels. The one on the left is the toolbar, where we have the different applications and analysis steps that you can apply to the data. Then we have the main panel where the options, parameters, and options for the carbon atom are shown. And finally, we have the history that shows what you have done so far in the application and gives you a full tracking of what's done and what datasets you have used. So I will cover a bit of the details of the tools and history, and also the workflow creation that is not shown here, but it's interesting for our project. So starting with the tools, tools allow you to perform analysis on your data. There are lots of tools with different functionality, from basic text manipulation to complex genomics applications, statistics, almost anything you can think of can be put here as a Galaxy tool. The tools are described with a XML file, which includes what are the input datasets it receives, the different parameters it needs for execution, the command it will use for execution, the outputs the tool will produce, and it also includes additional documentation like help, tests to ensure their correct functionality, dependencies, so you can move it easily from one Galaxy to another, and it will handle the different binaries and libraries needed to execute the tool. And also, it has the possibility to include citations in the form of a DOI, so you can include that tool in a publication. The tools are versioned, and you can have different versions of a same tool in the same Galaxy instance coexisting. This is done to ensure reproducibility. So if you run one analysis with version 1 of tool A, even if you install a new version, the previous one will be there available, and you can execute exactly the same analysis you executed before. Besides the basic tools that are available in the Galaxy default installation, Galaxy administrator can add new ones, and there is this Galaxy toolshed, which is a online application store with thousands of tools that are ready to use and can be easily installed by the local Galaxy admin. So I will provide a link later to this tool shed. There you can find lots of tools that, if you want them to be available, it's just a click away to have them available in our Galaxy instance. This is a screenshot of the description of a sample tool. I just took one randomly. This is one that allows to add a column to an existing dataset. Here you can see this is version 1.0.0 of the tool. These are the parameters of the tool, so it will add the value 1 as a column to the dataset number 3 that is called convert on data 2. This is another parameter that is about increasing the value or not. And here you have some tips, documentation, and so on. And if you click on execute, it will be added to your history and will be executed. So now that I mentioned the history, this is also a core functionality to provide reproducibility in Galaxy. So for every action that a user does in Galaxy, the history keeps information about it. So it can track the datasets that you upload, download to Galaxy, and all the datasets produced by the tools, all the operations performed on that data with the parameters, input, and so on of each tool executed. It includes information about the name, format, size, creation time, and other data-specific metadata, the tool ID, the version, the inputs, the parameters, the standard output and standard error of the execution of that tool, the state, so whether it's waiting, running, successfully executed or failed, and within a history, each item can be hidden, deleted, and purged, so you can show as you like your history. You don't have a single history in Galaxy. You can have as many as you want, and you have this history management feature. So here we have a screenshot of my history in the AGINFRA Plus Galaxy, and I'm showing 3 different history, and you can see what are the different tools I executed for some data. You see some have failed, the others are successful, this one is empty, and so on. You can create a new history at any time. The previous one will not disappear, and you can switch between them easily within this interface. And you can also copy datasets from one history to another, so you can save some disk space. The idea is that one history should match one of your analysis and should be given a meaningful name so you can understand what's going on there. The other main feature I wanted to cover of Galaxy is the workflows that also help in the reproducibility of analysis. A workflow is basically a series of tools and datasets actions that run in sequence as such operation, and you have different options to create such a workflow. You can, from your history, turn that into a new workflow. You can create them from scratch using a visual editor, or you can import a new workflow from an existing one that is getting from another Galaxy instance. Workflows can be reused over and over to reduce tedious work, also to enhance reproducibility. So you apply the same exact methods to all your data. The idea is that you can, if you want, change the parameters before rerunning a similar analysis and then just go. They can be executed on multiple streams of input, and it will produce different histories, so you can analyze them separately. And as any other Galaxy object, you can share them for publication within the community, and they can be annotated, viewed, shared, published, and import in the user interface. So this is a screenshot of the workflow editor. So you see this as before. These are the tools that are available. If I click on one of them, it will be shown here as a new box that I can connect with the others as I want. And when you click on any of these boxes, you will get here in the details the different parameters, the inputs, the outputs, and so on. And even if you create a workflow from history, you can further edit in this editor, and I will show you later on the demo. Yes, small workflow I created for this. So that was the Galaxy introduction. As I said, this was quite basic just to get started. Galaxy is quite a powerful tool, and it's used in lots of communities. So there is a lot of documentation, and at the end of the presentation, I have some references with tutorials and training material that can help to continue on learning about Galaxy. I will move now to the part more related to the project, how we are integrating Galaxy with the AGINFRA Plus VRE. So just before getting on the Galaxy and AGINFRA, I will get into workflows and AGINFRA Plus. So the definition and execution of workflows is one of the main requirements for the communities supported in our project. And in the context of the project, we have selected two platforms, C9 and Galaxy. And these are to be integrated in the virtual research environments. The idea is that we will, or we are developing and customizing on top of this workflow management system, or the D4Science technology, which is the technology powering the VRE, to be able to execute workflows created with these technologies, and also to invoke other VRE tools from the workflows platform seamlessly. In the case of C9, VRE users can import and execute this kind of workflows in D4Science and execute them in the Dataminer environment, and also get the results there and inspect them. And I will describe now what we have done for the Galaxy, which is also similar. The idea is that you can access this workflow platform within the VRE, and you can execute Dataminer algorithms from Galaxy, sorry. So the first thing that we need to do to have this in place is to have Galaxy understand and recognize the AGINFRA Plus users in the system. So to this end, we have developed a small WSGI filter that is able to capture the D4Science token to authenticate a user. WSGI is just the name of a Python technology for developing web applications. That is the thing used in Galaxy. So it's natural to use this kind of filter to include this functionality in Galaxy. The idea is that the filter retrieves the token from AGINFRA Plus and then connects the D4Science to verify its authenticity and to obtain the user email. That information is then passed to Galaxy via the remote user HTTP variable, and the token is also stored in a secure place, so any further interaction with the VRE, mainly calling the Dataminer algorithms, can be done with the right token of the user. So the idea is that with this integration, we have Galaxy here added as one of the possibilities of the analytics tool of the AGINFRA VRE. And when you click here, you will get into the Galaxy interface, recognized as a user. I will show it later. Yes, this screenshot is basically a backup if everything fails. The other part of integration is integration with Dataminer. So Dataminer is an infrastructure service providing a state-of-the-art data mining algorithms and modeling under the WPS, the Web Processing Services standard. This is one of the tools for analytics available for the VRE users, where they can run any existing algorithms on data stored in the VRE, but also they can import new algorithms, so it's very extensible and can bring new functionality easily. It includes functionality to manage the input and output data of the experiment, to run these experiments, and it has an historic view of all the computations done so far, including detailed provenance information following the Prof.O standard from W3C. So in order to integrate this system with Galaxy, what we have done is to include a periodic task that connects to the Dataminer WPS API to retrieve a list of the available algorithms and make them available as tools in Galaxy. So we take the WPS information, and from there create a tool description that will make it appear as a native Galaxy tool that is available as any other tool. For execution, that's basically, again, using the WPS standard to call the Dataminer. It will use a user token that is obtained via this authentication filter that we described before. And the outputs will be stored also in the Galaxy system. So this is an example of one algorithm that is available in Dataminer and Galaxy. Basically, you can see the information on both interfaces is the same. So you have the name, which is this Prapi get call pi. You have here some information published by Remy Frese. The same here, the date, so on. You have the different parameters, the server page size. You have here the same thing. And start computation here in the Dataminer and execute on Galaxy. So basically, you have the same thing on both systems, and you can use them as a native Galaxy tool. There are some caveats to with the current implementation regarding how the input and output files are handled. I mean, even with this, they can be used, and I will show how it can be done. But something to consider if you want to try. So the input files must be provided as URLs, because we have no easy way to discover the files from the Galaxy interface, because it's a different system of the D4Science VRE. So right now, you need to provide this URL that can be easily obtained from the Dataminer interface in any case. And for the output, it's stored as an HTML, which is one of the supported Galaxy outputs, with pointers to the actual outputs inside this HTML. And the thing is that right now we don't have enough information from the WPS system to really have automatic output creation with the exact format that we need. Still, we can easily convert the what is provided by the tool to other more friendly format as needed. And as an example, I have created a CSV extractor that basically takes one of the files and says, this is a CSV, so you can further create, treat it as so, and do whatever you need to do with that. So just one last slide before going into the demo, showing very roughly and high level the deployment of the system. This is running on the EGI Cloud Container Compute Service. Right now it's running on INFM Catania in Italy, and some virtual machines available there. And we are running on top of Kubernetes. We have Kubernetes with a Kubernetes ingress that is let's say the public facing part of a Kubernetes that will handle all the incoming connection. It's where we have a SSL certificate, so we are sure that the connection is secure. And from there we have the authentication filter that is described before, that it will parse anything coming from the user and create the right environment for the Galaxy. And that's able to do the WPS to the D4Science infrastructure. As I said, this is a very high-level view of what's available. And just to give you a hint, this Kubernetes is a very flexible and scalable system. So right now, this is a single container, but it's very, very easy to have multiple copies of this as needed in Kubernetes, or even extend it with more processing power behind it if needed. So right now we have the basic installation, but it can grow as needs of the VREs also grow. So it's demo time, and I hope you can still see my screen. Maybe we can have some questions if you want, or shall I just go directly to the demo?
I just have one question about the Dataminer algorithms that will be accessible. Is this depending on the VRE? For example, if I have Galaxy on my VRE, will I have access to only the algorithms that are on my VRE?
Yes, this is VRE dependent because the Dataminer is also VRE dependent. For this specific demo, even if the Galaxy instance is linked to the main AGINFRA VRE, I have on purpose used WP7, the food security algorithms, because I know you are the ones that have more interest in Galaxy from the beginning. So I have used that, but it's just a configuration parameters very easy to change. And the idea is that every VRE will have its own Galaxy instance. At the end, it's just another Docker container managing Kubernetes. So it's quite easy to create a new one. And for this instance, you will see exactly your own Dataminer algorithms.
Okay.
So this is a VRE of AGINFRA, the main page. So from here we have the analytics, and we have this Galaxy at EGI that will open this interface. So this is Galaxy at AGINFRA. If I go here to the user, you can see I'm logged in as myself. This is a user coming from the D4Science. Here you can see the tools. So right now we have the default tools available in Galaxy, but also the Dataminer algorithms. As I said, these are the ones taken from the food security, just because you were the ones with more interest on having Galaxy, but this is just a configuration parameter. So here you can see I have I believe it's 16 algorithms. So I can click on any of them, and you will have the information available from the Dataminer. So the name of the tool, some description, and the input parameters with some help about it. So besides this Dataminer, you have everything available in Galaxy by default. So you have things to manage the data, which are basically this. So just manipulating data. You have things regarding genomics. So lots of genomic views, some statistics, something about displaying. And then you have a lot of different data sources. You can click on them and download. These are basically genomic information. So you have lots of public servers where you can easily download stuff, and you can also upload files from your computer, and they will be added to your Galaxy instance. So the history is where I have everything I have done so far. I will rely on the history to do the demo. As you see, I have done some tests, some failing. And I will start with this very basic call. which is the current history. So if I click here, I can just rerun the job again. This is basically to have the input parameters correct, so I don't forget them. So this will execute this tool, the GeoChart, which is one of the, say, standard algorithms available in the Dataminer. This is the input file, the different parameters, and if I click execute, it will appear as a new thing on the history. It's just basically saying, well, this is okay, it's going on. And here I can see the details of the job. So the name, when it was created, the identifier of the tool, version, output error, the different parameters, the command line of the internal tool that is used, and so on. And it's already ended. And if I click on view data, this is what I say, this HTML output that is containing the different outputs of the Dataminer. In this case, I believe it's just images of, if I click on one of them, yeah, I will get this image. I can click on any of them. So, well, it's execution and the results of the thing. It also includes some more information, for example, the ID of the execution in the Dataminer, and some log of the computation that I will just show you with information. With information of all what has been done to call the algorithm. So the WPS details. And going back to the tool. So I created another history with a bit more complex case, which is this one. And here I executed one of the WP7 algorithms, which is kind of funny because we are running K9 from Galaxy, so a workflow from a workflow system. This produced a CSV file, so just to, which is this one. I will not open to not break the flow. And then what I did is to extract that CSV file, so it's available as a Galaxy dataset. And then I did a very simple conversion or manipulation of the file. So we have, I will open. So this is the CSV coming from the Dataminer. What I did is basically to remove the, convert it to a tab delimiter file, so Galaxy can properly handle it. The next one was removing the first row, which is the name of the columns. And the last one was doing a chart on this column because it's a numeric, so that could be an option. So this is a sample of some related tools being executed together to do some kind of analysis. And with this, I can go and say, okay, I want to create a workflow. So that will contain those steps. So if I create the workflow, I can go and edit that, and it will show basically this. As I said, it's quite basic, but it will show the different steps that I took to perform the computation. And if I want, I can go and say run the workflow. So yeah, sorry, I just moved the box. Yeah. Run the workflow. I will say, yeah, send it to a new history. I can further edit the different parameters of the tool if needed, but I will not do it in this case. I can run the workflow, and it will appear as a new history. I can switch to it, which is here. So right now it's calling the algorithm, and when it's done, it will go and do the next of the steps. This is basically what I wanted to show you from the interface. I think it's also again now a good time for questions if you have any. I saw something on the chat. Maybe I just open it. While this is running. So this one from Matthias. There is no standard about the tools. It's a, let's say, proprietary format of Galaxy. It's an XML file. It's quite detailed, but there is no, as far as I know, there is no standard for such thing. Let's go here. Well, this already ended, so I could go here again. Again, this is the HTML. Then I have the CSV. Then I put it as tabular data. I removed the first row, and then I did the plotting of the graph. As I said at the beginning, these are quite, let's say, silly examples, but I hope you get the feeling of how it works and what you can do. I have some more few slides to wrap up. Which basically what are the next steps. So we have now this available for the AGINFRA VRE. So please go and test it and give us feedback and ask for anything you may need, especially if you need new tools that are not available right now, but probably they are available as Galaxy tools. We can easily install them. We would like to improve the integration with the Dataminer. So if you have any feedback regarding how to deal with the input and output files, be very welcome. And as I said before, this running on Kubernetes is quite easy to expand and to make it roll. So as you start using it, we will also put more resources onto that. Some references with information about Galaxy, the Dataminer, and the AGINFRA VREs. So there is lots of tutorials, videos, and information about Galaxy. It's quite a well-documented project. So if you have anything, I believe that those things there cover most of the needs you will have. But in any case, you can also ask me. Yeah, that's it. So thank you very much. And if you have any further questions, we can go for that.
Well, this is Matthias. Thanks a lot for this very good introduction. Yeah, I like it very much, and I would like to share the link of this webinar with some people from our domains. So if we can get the link of the recording as soon as possible, that would be great. So then real questions come up from them, I guess.
Sure, and I will also upload the slides into the VRE so you can share them as needed.
Perfect, thanks.
on the sharing of this stuff, I would suggest the following a couple of actions. So first of all, we should try to have something on the website, and we should also try to possibly create data entry into the AGINFRA catalog with this kind of stuff. Because, you know, for what regards the dissemination, the larger is the set of channel we use, the better it is. So this is just a suggestion. And also, I would like to somehow highlight the following that to me didn't emerge too much. I mean, the idea to have some algorithm in Dataminer is because Dataminer might offer the computing capacity for running these computing intensive algorithm. And in its turn, Dataminer is capable to make use of computing capacity offered by AGI. So you see in the picture where you put the deployment information, I think that we should try to reinforce a bit the part on Dataminer, and even try to suggest why these two tools are somehow expected to complement each other. Enol, you don't know if you share this kind of feeling, but I really believe that we should somehow try to suggest, okay, to a user what are the benefits of the two platforms and why we really believe that the two are going to work in somehow in tandem.
Yeah, I agree, Leonardo. And sorry about not including that explicitly in the presentation, but I think it really makes sense to make the user understand which tool is better for each of the needs the user may have. So as you said, the Dataminer can have considerable computing power behind. So if you have a very big computation, it really makes sense to go for that. And you can use basically the Galaxy as a way to create the workflows that include this powerful computation behind the Dataminer.
Yes, this is one of the benefits that we should highlight, but also the benefit that integrating an algorithm within Dataminer also, you see, make it possible to use it in a very user-friendly way in a plenty of workflow. So there is a benefit of integrating something into Dataminer from the computing capacity point of view, but also from the reusability point of view.
Yeah, I agree. And in fact, I just wanted to show here, which I had it here, but I honestly forgot. So anything you do, it will be recorded here in the Dataminer platform. So here are the ones I just executed this morning. So you have the geochart, this get plan height, and here you have information about everything that was done to execute that application. So you still keep all the provenance information and so on, and can access the same thing from both Dataminer and Galaxy, which is also very nice.
Well, this brings me to one question. Is it possible to call now Galaxy from Dataminer?
Well, in principle, we should be able, because Galaxy has an API to run workflows, but I haven't explored that. So technically, I believe yes, we should be able, but of course, the devil is in the details.
Okay, thanks.
Okay, any other questions, comments? Well, if not, thank you very much. Thank you very much for your attendance and have a nice day.
Thanks a lot.
Thanks a lot, Enol.
Thanks, Enol. It was really interesting. Okay.
Bye.